All right, so standard position always starts on the positive x-axis. Our initial side, that's what the IS is, initial side, always starts here. And then the angles, typically if they are positive, they will rotate counterclockwise, the exact same way that you count the quadrants, like quadrant 1, 2, 3, 4, the same way, until you stop at a terminal side. So we have an initial side, it rotates counterclockwise, stop at a terminal side. Those are positive angles. If it's a negative angle, it's going to rotate clockwise, which in my head I'm thinking, well, if it goes down, it's negative. If it goes up, it's positive. But it's not really going up or down. It's rotating. Thank you. All the way around is how many degrees? 360. And then all the way around 360 is the exact same thing as 2 pi radians. They're the exact same thing, 2 pi radians. And then if I type 2 pi into my calculator, I get 6.28. If I type in 2 pi into my calculator, I get approximately 6.28. So when we talk about radians, there's a little bit over 6 radians. And where radians comes from is what they do is they take the radius of the circle. I'm going to, and they take the exact same measurement, but bend it around the circle. So it's like part of the circumference. They bend it around the circle, and we call that, well, it's the distance of one radius. But when we do that, the angle that is formed right here to the terminal side, that is called 1 radian. I'll do that. So they get the term radians from taking the length of radius and curving it around. You guys who are sitting in that column, like Peter and, yeah, so you just move the desk over. You don't have to stretch your neck the whole time. That's why usually I have them separated, but we had a test hospital and we didn't have time to fix the chairs. Okay, so if all the way around is 2 pi radians, that's approximately 6.28. That's why 6 radians is here. There's a little bit left, that's at 0.28. All the way around is 2 pi radians. What's halfway around? Pi. If all the way around is 2 pi, then halfway around is pi. When we talk about exact radian measures, there's a 0, and this is pi, and then all the way around is 2 pi. These are radians. What would be the top half divided into 2? What would be right here at 1/4 all the way around? It's going to be half of pi, which is pi over 2. Now, if I divide into 4 equal sections, the first section has of pi over 2. That's the measurement of that angle in radians. What is it in degrees? 20 degrees. What is the measurement of just this quadrant in radians? This one right here. Just this quadrant. Louder. What is it? Pi over 2. I mean, if I divide these evenly, each one of them is going to be pi over 2. So if I'm adding, like we did back in, I don't know, 3rd grade, if I add together this one is pi over 2 and I add a second one, then this is over 2, or it would be 2 over 2. And if I keep going and I add a third one on, I'm going to add a third pi over 2 on, then this third angle down here is pi over 2 each time. What would be the fourth one? It's going to be 4 pi over 2, but we don't write it as 4 pi over 2. We always reduce it, so it's 2 pi. So what if I kept going and I went one more? 5 pi over 2, what if I went another one? 6 pi over 2, what if I went another one? 7 pi over 2, what if I went another one? 8 pi over 2, no, it's not 0. 9 pi over 2, 10 pi over 2. I could keep going on for how long? I'm not going to do that, but you can keep going around and around and around and around because the circle, it never ends. All right, let's look at this one here. 0, comma, if I go all the way around here. If I go halfway around, it is pi. Okay? And I think when we talk about radians, it is easiest for me to think about radians in terms of pi, not in terms of the whole circle. I think it's easiest for me to think about pi rather than the whole circle. If I divide the top half into 4 equivalent pieces of pi, if I divide this pi, which is the top half, if I divide it by 4, what is the measurement of the first section as radians? It's pi divided by 4. Because that's what I just did. I took the top half, which is pi, into sections. It's pi divided by 4. What is that as degrees? 45. So now if I count 2 of those, first pi over 4, second pi over 4, that one reduces to pi over 2. If I count 3 of those, 3 pi over 4. If I count 4 of them, 4 pi over 4, which reduces to pi. So going all the way around the circle with exact radian measures, we would next have what? 5 pi over 4. Then 6 pi over 4, which reduces. 7 pi over 4. 8 pi over 4. From previous course, what is the other one that we typically divide by that's pretty important? Louder? Okay, I heard 6 and I heard 3. You're both right. I'm going to divide the top half pi into 6 equal sections, and then we'll talk about 3 after that. I'm going to divide it into 6. Oh, that wasn't a good one. Wasn't accurate enough. Okay, I did my best, but it's not very good. 6 equal sections. So if I take the top half and I divide it into 6 equal slices of pi, what's the first one? That's pi divided by 6. That's pi over 6. Degrees-wise, just take 180 degrees and divide by 6. What is it, degrees? The next one is 2 pi over 6, but that reduces to pi over 3. Pi over 3 is 60. So when you guys yelled out pi over 6 or pi over 3, you're both right, but they both relate to pi over 6s. So if I'm counting by pi over 6s, then we're going to have 3 pi over 6. But that's it. Then we will have 4 pi over 6. But that is 2 pi over 3. And we'll have 5 pi over 6. 6 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6. 10 pi over 6 is 5 pi over 3. 11 pi over 6. No. So I'm going to color the pi over 3's in a different color on top. The pi over 3's. So the ones that reduce to pi over 3's, I just colored a different color. Those are our 60 degrees. And then the ones that stayed green are all over our 30 degrees. Now you can divide the pi half. You can divide anything you want or anything that I give you. Could I find where pi over 9 is? Can I find where 9 is? How? Oh, if I want to think degrees, yeah. 180 divided by 9 is what? 20. So if I want to like envision, here's 90, 20 degrees, maybe about there. But just visually, what could I do to find where pi over 9 is? Neil? Divide what into 9 sections? Just the top half of the circle, right? So the whole circle would be like 18. But yeah, just the top half, which is not that easy to draw equally segments. Yeah, I don't know if I'm doing it right. Did I do it? 1, 2, 3, 4, 5, 6, 7, nope, 8, 9. There we go. I'm not going to be that accurate with it because that one's like one that we don't use that much. But it doesn't matter what radian I give you. If you take the bottom number and you divide the pi by that number, you will have those sections. What if I wanted 4 pi over 9? I would still do divided by 9, but then I just go 4 slices. There's 4 slices, I think. 1, 2, 3. Nope, that's 4 slices. Just do the first 4 slices, right? Okay. Rotation, that's around the whole circle. That's not just pi. That's around the whole circle. So when we sketch it, what you have to have on your paper is you have to have an initial side. You need to have a terminal side. I'm going 1/3 around the whole thing. How can we think about that? Do you want to think about it as degrees? Is that the easiest way for you guys? That's the easiest way for me. What's 360 divided by 3? 120. So that's about here. So I have to have a terminal side. And then the third thing that you show me is which way it rotated. So you have an angle arc that shows me which way it rotated. The next one, 7/4 rotation. 7/4. That means if the entire thing was divided in fourths. This is not talking about pi. It's talking about the whole thing, 7/4 rotation. If the whole thing is divided into fourths, which it is, I'm going to do 4 of them. I mean 7 of them. So my initial side, and then I'm going to use my pink pen to go, here's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4 rotation around the entire thing, and that will be my terminal side. If you take it and you do 7/4 multiplied by 360 and find that degrees, that's another way that you can figure out where to put your. But you still need to show that you went around more than once. Okay. What angle is this besides? What angle is this down here? In degrees. In degrees. 270? Okay. Is that the only answer? What's also? Say it again. Not 90. Oh, I heard it over here. Who is negative 90? Because remember, 90 going down is going to give us negative 90. So negative 90. Now, I heard other answers, but I weren't listening. What else were you saying? 540? How'd you get that? Okay, so 270 times 2, 540. Hold on a second. I got to do this right here. So if I have 300 degrees in a circle, and 540, and I take away 360 in a circle, that leaves me with 180. 540 is actually go around the circle once and go around to 180 more degrees. So that's not 540. That would be go around the circle once and then go around how much more degrees? Be 360 plus 270, 630 degrees. How do I get from this green line around again to hit the green line again? It's a 360 degree difference. So I could either go counterclockwise and add 360, or I could go negative 360. I could go clockwise and subtract 360. These are all called coterminal angles. Coterminal angles are the ones that end right at as like 30 degrees. I need another angle that ends right there. So here's 30 degrees. What's another angle that would end at 30 degrees? 390, because I'm going to take that 30 and I'm going to add 360 onto it. Oops. 360. So that's one of them. This asks for one negative and one positive. So can we give a negative angle that goes negative 330? And to get that, you just take 30 and you subtract 360. So if you're adding 360 or subtracting 360, you're going to get answers. Let's look at number E. It's not number. Letter E. When you look at this pi over 3, is it degrees? What is it then? How do you know it's not degrees? The answer is not, because there's pi in it. What? Who knows why? Thank you, Prab. Did you learn that last year? Okay. Thank you, Prab. I know that this is not degrees, because if it's degrees, there will be a degree symbol. I could, don't write this, but I could do this, and then it would be degrees. We don't usually have that, but if it doesn't have a degree symbol, it is radians. Okay? So this one's radians. So I'm not going to add 360 and subtract 360. What am I going to add instead? I'm going to add 2 pi. So I have to do pi over 3 plus 2 pi. Oh no. Common denominator. We can handle it. Pi over 3, my common denominator would be 3. So I multiply my pi over 1 by 3 over 3, which gives me 6 pi over 3. So that would be 7 pi over 3. Positive answer. To get my negative answer, let's subtract 2 pi. Or subtract 6 pi over 3. Negative answer would be negative 5 pi over 3. So we are adding or subtracting 360, or adding or subtracting 2 pi. Okay, the next section is DMS, degrees, minutes, seconds. This is where you might want your calculator. So if you don't have it and we have time, you can go get it. If not, just write down good notes. It's really not that much. And I'm making a video, so you could always watch this video later. So degrees, minutes, seconds are, they're a way of measuring degrees with super accuracy. And some professions use this. I know if you are in the surveying business, they use degrees, minutes, and seconds to measure land, rather than using 25.2625 degrees. Instead of using that, they use what's called degrees, minutes, seconds. So we have our degree symbol. We've got apostrophe, which means minutes, and we've got double apostrophe, which means seconds. To do this by hand, minutes is always a fraction of 60, and seconds is a fraction of 3,600. So to do this by hand, you would have to add together 25 degrees plus 15 sixtieths plus 45 3600ths. And then you'd find each decimal and add those together. okay? Our calculator, however, does have a mode that you can just switch stuff to, so I'm going to show you how to use that mode real fast. If you have your calculator, you can just write down what to do. It is really easy. It's all over the internet. You can find it. So we're going to type in degrees, minutes, and seconds. So we're going to type in 25 first. And if you're going to do degrees, minutes, and seconds, you're going to have to use the button that says angle on it, which I forget where it is. Oh, it's right here. Second, apps has angle. And then you'll see choices for degrees and minutes. So I'm going to hit the degree symbol. 15. And I'm going to go back to second angle. And the number 2 is minutes. And then I'm going to put in 45. But seconds is not under the angle, because why not? But instead, I mean, and it's somewhere else, and I forget where else it is, but instead it is second plus sign. Nope, yes, nope, alpha plus sign. It's alpha plus sign. It's alpha plus sign, there it is. So alpha plus sign, and then you hit enter, and it will convert it into degrees in decimal form. Now it says use calculator to convert. Oh, that's what we just did. Now we're going to convert something from decimal form back to degrees, minutes, and seconds. So the next example here says type in 9.025, and we're going to convert that into degrees, minutes, and seconds, and that is also under the angle button. There is a button that says convert to DMS 4. Enter, and it tells you the answer. So it's really quick. It's almost all under the angle. Okay. So which quadrant is the angle found? I went over earlier that the quadrants 1, 2, 3, and 4 go in counterclockwise. Somebody told me that it makes a C for coordinate plane, I guess. I don't know. Criswell. You just have to draw 110 degrees and sketch, draw it and say which quadrant it's found in. So we will have an initial side. You guys should know where 110 is. We'll have an arc that shows which direction we rotated. And you're going to quadrant 2. That is I. Just out of curiosity, how much would be left to get us all the way to pi? Just out of curiosity, how much would be left? 70 degrees? That's called a reference angle. Reference angles always go to pi or 2 pi. We'll be studying those, but why not tell you about them now? All right. 240 degrees, 30, what's that stand for? Minutes. So we're going to sketch it. We have our initial side. And I'm going to rotate to 240 degrees, 30 minutes. Oh, gosh, how do I do that? This is 180 degrees. The bottom one's 270, so we're not going to go quite that far. But how do I do this 30? Oh, it's half of a degree. Okay, I can't really be that accurate, let's be honest. Right? Yeah. So, I don't want it to confuse you. Can't be that. I just can't draw it that accurate. So there's my picture. Just out of curiosity, how far is it to get to the pi, to the x-axis? How far is that? Is it 60 degrees? To get to 180 degrees is how far? I keep hearing 60 degrees, but 180 plus 60 is not 240.3, or not point, but 3. What is it? 60 degrees and 30 minutes. Oh, that was hard. There you go. Are we? Who doesn't get it? What don't you get? My reference angle thing?
Yeah.
It's just like how far past 180 did I go?
Okay.
So I basically took this 240 and subtracted 180. 240, 30 minutes. Like a decimal, but not written in decimal form. So if I subtract 180, I'm going to get 60, and I still have this left over.
Why do you have this left?
It would be the same thing. So this as a decimal, this 30 minutes, the same thing as a decimal would be 240.5 degrees. These are equivalent.
Okay.
So if I took away 180, would you see how there would be like a 0.5 left over? I'd get 60.5. So the 0.5 is 30 minutes. 30 minutes out of 60 is a half. Negative 350. So I'm going to go initial side at 0. I'm going to go negative. Way around. We're going to end up in which, oh, I forgot to say which quadrant that one was. We're going to end up in which quadrant for C? 1. Which quadrant was? Okay. By the way, how much would it be left over to get to that axis? 10 degrees. That's a reference angle. Okay. You don't have to do the reference angles, but you will be doing the reference angles. I'm going to show them to you as much as I can. All right, how about 7 pi over 8? Oh, no. How do I draw that? Who wants to talk? Oh, I just have to call on somebody. Neem, you want to talk? Nope. But I guess you could if for desperate. We don't know what to do. We desperately make it into degrees. Dylan, you know what to do? Okay, what if I took away the 7? What if I just said pi over 8? Cooper, you know what to do? Divide the top half, which is pi. If you divide it into 8 equal sections, there's 2, there's 4. Oh my gosh, that was terrible. Divide it into 8 equal sections. Now, how many of them are we doing? Katie. This is the foundation of everything we're doing for the next 3 months. The things right now, you might have trouble in here. That would be 7 out of 8 pieces. 7/8. 7 pi over 8 would be right there. And which quadrant is that? Second. How about negative 2 pi over 3? If I have just pi over 3, what am I dividing it into? Dylan, what am I dividing it into? Thirds? This one's negative, so which half am I dividing into thirds? The bottom. It's about 60 degrees into thirds. And then how many of them how many thirds am I going to use? 2 of them. And that'll be the third quadrant. All right, last one. Negative 5 radians. How's this one different than the past two I just did? Oh, the past two I just did were also in radians because they did not have degree symbols. How is this one different than the past two I just did that were also radians? How's this one different? Yeah, there's not. It's okay. Kind of. You're on the right track. What else? There's no pi. It's because pi was already multiplied in there. Like if I take pi and I type it in my calculator, it tells me 3.1415926, right? So pi was already multiplied in here. This is a decimal version. So all halfway around is what pi? 3.14. All the way around is what pi? 6.28. So where's 5? What is in between? What is, no, different question. What is half of pi? What's half of pi if I divide this by 2? 1.57. Okay, and then if I add 1.57 and 3.14, I'm going to get this one down here. 4.71. So where's 5? You see, it's kind of in that fourth quadrant, except this is negative. So we're going to go the other way. So instead of the fourth quadrant, it's going to be, instead of the fourth quadrant, where's it going to be if I'm going the other way? Our first quadrant, somewhere in there. So that would maybe be the most difficult thing, is when they don't give you the pi. All right, we're almost done. You guys in geometry and prior to geometry as well talked about complementary and supplementary. Who remembers what complementary stands for? They complement each other. They tell each other nice things. Audrey, do you know what it is?
It's like the one that like it's across, not across, but like.
Those are vertical. I think you're thinking of vertical angles.
Is that like the one that it's like if it's not next to it, but like it's the same as like.
I think you're thinking of corresponding angles. Katie. Or Kate. Wait, you're Kate. Sorry. Kate. Yeah, the sum of the two angles is 90 degrees, yes. So now, what's supplementary? Jalen? Yeah. So complementary, the sum of the two angles is 90 degrees. Supplementary, the sum is 180 degrees. You can see that, oh no, these first two examples are not in degree form. So what is the radian version of degrees? It's pi over 2. And what is the radian version of 180 degrees? Pi. So if we find, if possible, find the complement and supplement of the volume and angles, we and supplement of 5, then we take pi over 2, which is that 90 degrees, and we subtract off over 5 to find out what the other amount would be to make. So we take the 90, we subtract off the piece to find the other piece. We're also going to take pi, and we're going to subtract off 2 pi over 5, and that's to find the supplement. So this is the complement, and this is the supplement. We need common denominators, so tens. 5 pi over 10 minus 4 pi over 10 equals 1 pi over 10. That is my complement, 1 pi over 10. And then 5 pi over 5 minus 2 pi over 5 is 3 pi over 5. That is my supplement. So same thing here for doing complement and supplement. We're just going to subtract pi over 2 minus 4 pi over 5. We're going to subtract pi minus 4 pi over 5. Common denominators, 5 pi over 10 minus, wait, just, no, that's right? No. Yeah, that's right?
Yeah.
Why can't I do that? Oh, yeah, minus 8. The second one I was doing wrong. Okay, 8 pi. And what do I get? All right, so what I get is there is no complement. Why did I just say that? Because I think it was Prob just yelled out an answer. From that direction. Why is there no complement? You clearly got negative 3 pi over 10. Why is there no complement? Who can use their intuition to figure that out? It's a negative number. Complementary angles would be two angles that add up to be 90, not two angles that you have to subtract to get 90. Like 4 pi over 5 is already bigger than 90. It doesn't have a complement. And then pi minus 4 pi over 5 is, how many pi over 5s? Pi over 5. So it has a supplement, doesn't have a complement. And then the very last thing is to convert. If you are interested in converting, which we are not going to do a ton of in here, but we will do it on occasion. To convert degree to radian, you're going to, actually we're going to do a lot of converting in general in here, but just right now we're doing degrees. Anytime you convert stuff, you have to multiply by a value of 1. This is a value of 1. If I take pi radians and 100 degrees, they have the exact same value. They're just written as different units. Just like you guys might say 12 inches or 1 foot, that's the same measurement. They're equivalent. We're just changing units. So that's what's happening here is we have degrees, and we're going to multiply by 1. We're going to multiply by a value of 1, but it's going to change the units. So to multiply by a value of 1, you have to multiply by, cancels out degrees on the bottom. And you have to put in radians on the top. So that's how I remember what to multiply by, is I need my degree symbols to, if I have degrees, then I have to divide out the degrees. And then we multiply straight across pi over 180, and you do reduce to 3 pi over 4. We're not going to give a decimal answer. 540, that is degrees, so I'm going to have to put degrees on the bottom and put what is equivalent on our pi radians in 180 degrees. Multiply straight across, and my degree symbols cancel out. And I get 3 pi radians. Negative 270, same thing. My degree symbols cancel out. I get negative 3 pi over 4 radians. Okay, and then to convert it from radians to degrees, since this is radians on top, you have to multiply by degrees on top and put the radians on the bottom. So you think about canceling your units. We're going to be doing real-life application in here. We're going to be doing physics-related stuff in here. And so anybody in physics? Anybody? Yeah. You guys remember how, like, first day of class, you probably did all this, like, conversion stuff? Yeah. And then we go straight across, and my pi's will cancel out, and I'll get negative 182, which is negative 90 degrees. I'm just going to skip to the last one. 2 radians that does not have a pi in it, but it is still radians. See the word? It's radians. No degree symbol. So I'm going to multiply by 180 degrees to give it the degree symbol. I'm going to divide by pi radians. I'm going to go straight across, and I'm going to get 360. My radians cancel, but on the bottom the pi does not cancel. A pi in it. My answer has a pi in it, but if you did want to find a decimal, then you would just divide by pi in your calculator. Approximation, that's a rounded answer. Okay, but just because it has a pi in it does not mean it's radians. Okay? Just has to do with converting it. It's the degree symbol that tells you that it's degrees, or the lack of that tells you. Our assignment's actually in a book. Now what I did is I posted the book on Canvas. If you want a book, we can start checking out books today. There's the book here. And then if you click on book link, there's the exercises from the book. Okay. So it's all there, what you'd need. No. I mean, you have to do all the questions that were listed, which seems like it's not. It's not really bad. I'll put it up so you can see it. But you could do just numbers 1 to 77 all. Your choice. You know, you can choose which one you'd like to do. Okay? It's up to you, Peter. Let me stop my video.